Hey guys, welcome to this brief tutorial lab on Google Cloud, where I'm going to be demonstrating how to use a Spotify songs dataset in order to create embeddings, store them in a vector database on Google Cloud, and then eventually retrieve them using simple search queries. So the dataset has been taken from a public repository, as you can see on my screen, and it has roughly 20,000 Spotify songs. Now, each song has a unique identifier, which is called a track ID. It has the name of the artist, the name of the album, the name of the song or the track, and a bunch of other attributes that apply to that specific song. All right, so you can see the popularity, duration, danceability, energy, and so forth. Now, we're going to be creating embeddings out of the attributes that we feel is necessary for a song to be defined or described. All right, and then storing them in a vector database. So, overall, the services that we're going to be making use of in this tutorial are the Vector AI, Vertex AI text embedding model. This is a library within Vertex AI ecosystem that we can use in order to create embeddings out of your text input data. We'll be using the vector search, which is nothing but a vector database, a fully managed vector database offering on Google Cloud. And then we'll be using the public search endpoints where we'll be deploying our vector database in order to query it and retrieve the results from the vector database. All right. The entire execution for this tutorial will be done on cloud, meaning on Google Cloud. And I'm going to be executing the code inside a workbench in Vertex AI. So on that note, let's begin by creating a simple workbench on Vertex AI. So let's begin by heading over to Vertex AI. So just type Vertex AI from your GCP console and then select Workbench. Now let's click on Create New. I'm going to be calling this, let's say, Spotify Songs Workbench. The operating system is Debian 11. Environment, I'm just going to select Python 3. Now let's click on Advanced Options. Now let's click on Machine Type. And I'm going to select the smallest machine type available, which is E2 Standard 2. It has 8 gigs of memory, which is more than enough. Most importantly, let's set the idle times shutdown to 30 minutes, which basically means your workbench is going to shut down in case you're not using it for more than 30 minutes. And this is important because you don't want to end up spending unnecessary money when you're not using the workbench, right? So that should be it. Everything else is fine. Now let's click on create and give it a couple of minutes until we can start using the workbench. All right, so the workbench is up and running. Now let's open up our Jupyter lab. And as a first step, we're going to upload the two files that we need for this tutorial. So the first one is our input dataset, which is called music.csv, which contains 20,000 and odd songs from Spotify. And the next one is the IPython notebook, which contains the Python script. So I'm going to drag and drop them here. Now let's go over the Python script. So first, we just do a quick upgrade of Google Cloud AI Platform and Google Cloud Storage. So let's run this. It says you may need to restart the kernel. So I'm going to click on kernel and restart it. All right. We then import pandas, the text embedding model from Vertex AI. We import Vertex AI itself, TQDM and time. Then we set the project ID. So let me change it to my project ID. I'm using US Central 1 as my region. Music.csv is the input file or the input dataset. We initialize Vertex AI and read music.csv into a pandas data frame. So if you do a df.head, everything looks good. Now, like I mentioned, the dataset contains 20,000 and odd songs, and we're trying to create embeddings, or we're trying to work with embeddings, right? In order to create embeddings of 20,000 and odd rows of data with several attributes that we'll be using, it's going to take a lot of time. It's a time-consuming process. So in order to avoid that, I'm just going to select the top 100 rows or 100 songs from my input data frame. So let me run this. Now my data frame only has 100 songs. And next we create a new column called combine underscore details. Now this column is nothing but a concatenation of all these columns that you can see. So I'm selecting the track name, popularity, duration, danceability, and so forth. Now you can feel free to reduce the number of attributes, or you can add more attributes if you wish to. It's totally up to you. But I'm only selecting roughly 6 or 7 attributes that I feel is important. Let me run this. And next we create an object of text embedding gecko model. This is the text embedding model offered by Google Cloud. 001 is the version number. So I've defined my model object. Next, we create a function called getEmbeddingWrapper, which accepts 2 arguments. The first one is the text itself, and the second one is the batch size, which has a default value of 5. All this function does is accept text and return the respective embeddings. That's pretty much it. Let me define it. And now we convert the combined details column that we created here to a list, and then we pass it to the function getEmbeddingWrapper. So by the end of this execution, or this code block's execution, we'll have a new column called embedding in our pandas data frame, which will have the vector representation of the combine underscore details column. Let's run this. And this is the part which I said could be time consuming if you are working with thousands of songs. And now that we're only working with 100 songs, it should be pretty fast. All right, so we're done. Now let's do a df.head. You scroll all the way. You'll see combined details, which is a concatenation of other columns and the respective embeddings for that specific row. All right, so every row has its embedding. Now that we have the embeddings, the next step is to write these embeddings into vector search, right, which is a vector DB on Google Cloud. Now for that, we will first write these embeddings to a JSON-L file or JSON file, and then feed this JSON file to vector search when we create the index. So here I'm selecting ID, track ID, artist, album name, track name, and embeddings. You need not select all these columns. You can only select embedding if you want to, because that's the most important. And that's the data that we want to store in a vector database, right? So what we're doing is selecting all of these columns and writing it to a JSON file called songs.json. So when I run this code block, you should see a songs.json file. There you go. So that's your songs.json. And then we copy the songs.json to a GCS bucket. So make sure to change the bucket name. Also make sure to create a bucket to begin with if you don't have one, and copy the JSON file to it. All right, it says operation completed. Now, if I go back and I do a refresh, it says deleted, which is weird. Okay. All right, there you go. So you have songs.json. Now comes the most important part. Now, typically when you're working with a vector database offering, especially on cloud, the first step is to create an index using the data or using the embeddings. And then you create an empty endpoint. And the last step is to deploy this index to your endpoint. All right. So to create an index, which is the first step, we invoke the method create tree ah underscore index. This is a custom name. I'm calling it Spotify songs IDX. Bucket URI is the location of the JSON file, which contains our embeddings. 768 is the number of dimensions since we're dealing with textual data. 10 is the approximate neighbors count. And this is the number of similar search entities that will be returned. All right. We're using a dot product distance as our distance measure. You have several others such as cosine similarity and so forth, right? In this case, I'm using dot product distance. So let's run this code. And you can see it says backing LRO. LRO means long running operation. And as soon as you execute this code block, you can go back to your Vertex AI dashboard, click on vector search, and you should see your index is being created with 100 songs from your GCS bucket, which is right here. Now, this shouldn't take too long because we're dealing with a very small amount of data, but I'll return once the index is done creating. All right, so the index has been created. Next, we create an endpoint, and I'm calling it songs endpoint. You can change it to whatever name you wish. And to create an endpoint, we invoke the create method from matching engine index endpoint. Matching engine is the former name of Vertex search. So that's why it's called matching engine index endpoint. Let's run this. All right, the index endpoint, the endpoint has been created. Since it's empty, it shouldn't take too long, as you could see. Now, if you go to index endpoints, you can see songs endpoint that I've recently created. Now let's come back. And now I'm going to deploy the index to my endpoint. So it says index endpoint dot deploy index. Index endpoint is this one right here. And for index, I'm saying my underscore index, which is the very first step that we performed when we created the index, right? So it's a reference to that. And then deployed index ID is nothing but a custom name, which is called Spotify underscore songs underscore index. Now let's run this code block. And this is the last step, which is going to take about 15 to 30 minutes, uh, something in that range. So I'm going to pause the video now and I'll return once the index has been deployed to the endpoint. Okay, so the operation is completed successfully. Now the code execution does not show complete here in the notebook because my notebook reached the idle time, and that's quite normal. In your case, if you leave it up running, uh, chances are you'll lose the connection and you will not see the output here outside the code block that you've executed it in. In such cases, what you can do is you don't need to run the entire code block again from the Jupyter notebook, obviously. So what you can do is go to Vertex search, click on your index, and if you scroll down, your status now should say ready. All right, after let's say 30 minutes or 30 to 40 minutes, which is the time it takes to deploy an index to the endpoint. And from here, click on the endpoint, and you can grab the ID, which is your endpoint ID from here, and just replace the last segment of the URI with your endpoint ID. That's it. Okay. So this is how you can use a deployed endpoint. So I've created the endpoint again now that I know my index has been deployed successfully. And now that's pretty much it. We just need to input the search query in order to get the results. So to begin with, I'm going to say recommend some happy songs. You can even say recommend some songs which are similar to another song. You can try out different prompts here. And what I do is I take the user prompt and I convert them to embeddings, all right? Because the vector search compares embeddings with embeddings, right? So I create embeddings out of it, and then I pass it to find neighbors function, which is being invoked using the endpoint. All right, this is my deployed index ID, which has been defined above. This is my embedding. The number of neighbors, I'm setting it to 5 because I'm expecting 5 results back or 5 songs back. And I just run a simple for loop through the response. That's pretty much it. Now you can play around with what I've done here. So I'm doing a match by ID, meaning I'm getting the ID of the returned songs so that I can do a lookup later on. Let's run this code block and see what happens. All right, there you go. So this is the ID. This is the name of the song. And what you see here, which is 0.6181, which is nothing but the percentage of similarity, meaning the first song has a 61% resemblance to what you asked. It's the closest match. And everything after that is lower in values. As you can see, the next one is 59. In fact, all 4 are 59. Okay. So you can change the value to 10 and run it again. And you get 10 results now. And the closest or the max value is 61% here, which is the closest to a happy song. So I would recommend you guys try out different prompts, go through the data set, find songs which are quite similar, and then try to come up with a user prompt by saying recommend me songs which are similar to the song that you found out. So there's a variety of prompt engineering that can be done with this. That's it for this video. I hope you enjoyed it, and I hope you've learned how to use Google vector search. It can be applied across a variety of different use cases, such as similarity search, recommendation engine, and so forth. So let me know in case of any questions, and make sure to like and subscribe. Thanks a lot for watching.